Welcome to Ask and Learn.
The equation we're given here in this problem is the time that a patient spends on dialysis as a function of the concentration of urea in the blood. And we're going to find its derivative. And the derivative is going to be how the amount of time spent in dialysis changes as the concentration of urea changes. So that's the interpretation. So let's go ahead and do the calculation. But first of all, if you think about the log properties that you've learned in the past, you can use the quotient property of logarithms to change how this equation looks before you differentiate, and that makes it a little bit easier. So the log of a quotient is a log minus a log. So we can change this to the natural log of the numerator minus the natural log of the denominator. And because the natural log of 2 is just a constant, when we differentiate, it's just going to be 0. So the derivative of t, remember the derivative of natural log is 1 over the inside times the derivative of the inside. So we would have 1 over 3c plus the square root of 9c squared minus 8c multiplied by the derivative of that inside. And that would be 3 plus 1/2 times the quantity 9c squared minus 8c to the negative 1/2 times the derivative of the inside of that, which would be 18c minus 8. Okay, we can clean that up a little bit. I don't think it's necessary to simplify it a huge amount, but what we could do is write it as 3 plus, and now notice that we have a 1/2 and we have another factor that has 2 even numbers in it, so let's multiply the 18 and the 8 by 1/2. So we have 3 plus the quantity 9c minus 4 over the square root of 9c squared minus 8c, and that whole thing is over 3c plus the square root of 9c squared minus 8c. And I know that we do sometimes simplify things like this, but for the sake of this problem, I don't think we necessarily have to simplify that. Again, that tells us how the amount of time in dialysis is changing with respect to the amount of urea in the blood.